try. So if not, such is life. Okay, so when we're talking about solving systems of linear equations, we can solve them by graphing. Did that. Again, that's the least effective because it's not always an integer for the point of intersection. Second method, substitution. Just dealt with that. Third method now, elimination. Again, matrices will come later on. So now you have to shift your attention because the way you begin the elimination method, also called the addition method, is different than substitution. So go back to last night when you were doing substitution. You had two equations and you had to decide. First equation, do I solve it for x? Do I solve it for y? Second equation, do I solve it for x? Do I solve it for y? So you had to look at four different things to decide what am I going to go for. In elimination, you now have to decide, am I going to eliminate the x variables or am I going to eliminate the y variables? So that's the thought on these. Am I going to eliminate the x's? Am I going to eliminate the y's? And by the way, the variables don't always have to be x and y. They can be a and b. They can be other things. Same principle though. So do I want to get rid of the x's? Do I want to get rid of the y's? That's what you're looking at in the elimination method. So first thing is get one of the variables. And we always use x or y, but it doesn't have to be, to add out. That's what you're after. Get one of the variables to add out. So that's different. All right. How do you do this? What do how are you going to approach this? How are you going to think to do this? You got to look at the coefficients. Look at the coefficients, right? The multipliers of the variables, to make a wise choice as to which variable to eliminate. This is how everything needs to start here. Can you still get it right doing the wrong variable? Yes. And there's no right wrong. It's like better and not as good. And sometimes way better and way worse. It just depends on the system. So a wise choice in the beginning sets the problem up to be a lot easier for you, and therefore then you got to be careful and think it through in the beginning. Okay, so how do you do that? What your goal is you're going to work to get the coefficients, right, the multipliers of the variables, to be equal and opposite. So they will add out. Get the coefficients of one of the variables, and I mean the x's or the y's, to be equal and opposite, so they'll add out. That's why some call this method the addition method. This curriculum used to call it the addition method. Now they call it the elimination method, and that's probably a more generally known term, is elimination. But what you're after is getting either the x's to add out, because if you got a 3x and a negative 3x, guess what? When you add them, you get 0. You got a negative 7y and a positive 7y, guess what? When you add them up, you get 0. They add out. That's what you're after. Either to get the x's to add out or get the y's to add out. How do you do that? Get their coefficients to be equal and opposite. Okay, so let's just get into it, and let's just, again, practice setting up the problem. So on these first three, all we're going to do is try to figure out, what do I want to try to get rid of, the x's or the y's, and then how do we do it? All right, so that's your first choice. And so I've highlighted the coefficients. The coefficients of the x's are in red, the coefficients of the y are in green, and you got to decide, do I want to eliminate the x's or the y's? And this first one I hope is an easy choice. You would get rid of the y's, because the whole point is we want to add the two equations. And if you were given something like this, you would kind of say, great, this is awesome, because they're already ready to add up, right? You'd get a negative 4x, your y's are 0, And now you have the equation negative 4x equals 4. And guess what? X is going to equal negative 1. You've already got the x value. You can figure out the y value. Okay, we're not finishing the problem. My purpose right now is just get you to remember and understand how to begin the problems. So when I looked at those y's, I said, oh, wow, they're already equal and opposite. They're all ready to add. So how do you do it? Just add them. Add the equations. They're already ready to go. Is it always going to be that nice and handy? No. But it might be. And in which case, you're ready to roll. So again, you were looking at the red 3 and the red negative 7 and say, those aren't very nice. But hey, positive 2 and negative 2 y's, they're ready to add. Therefore, I'm going to choose the y's. All right, second scenario. So now you look at a 4x and a 2x. And then you look at a negative 7y and a negative 5y. And you got to decide, do I want to try to get rid of the x's? Do I want to try to get rid of the y's? So make your choice, x's or y's. All right, and your choice is what?
X's.
X's is the easiest just because the numbers are smaller. So I would go for x's. So how are you going to get rid of the x's? Anybody remember? Raise your hand and tell me how to get rid of the x's. Kyle?
Actually, multiply the 2x by 2.
Okay, so just the 2x by 2?
Only negative 2.
Okay, multiply by negative 2. And what specifically do I multiply by negative 2? Just the 2x? Like this? Trying to get you to remember. You're close, Wesley.
You do the whole bottom equation?
Yeah, you have to multiply the second equation by negative 2. Multiply the second equation by negative 2. It's the same concept as unreducing a fraction. If I had 3/4, could I multiply the top and bottom by 2? I can. I get 6/8. Isn't that still 3/4? You can do that with an equation. If you multiply the whole equation by the same quantity, then all you're doing is like unreducing the equation. But it's exactly the same still. So we want to multiply the whole equation by negative 2. Okay, again, I'm not going to finish. We'll deal with the semantics of that when we get to the actual problems. But that's how you would approach that that second one. All right, the third one. So now I got the first equation in black, the second equation in blue. But again, you're thinking, do I want to get rid of the A's? Do I want to get rid of the B's? And again, it's just this one, there's no easy choice, except that if you go for the B's, your numbers are going to be so much bigger. So I would go for the A's. But what I want you guys to think about is, how are you going to get the A's to be equal and opposite? So think about that for a moment. What can you do to get the A's to be equal and opposite? Somebody raise your hand, give me what to do on this one. Is there anybody else in the class besides these three guys? Justin?
Multiply the top equation by negative 2 and the bottom equation by 3.
And I would agree. So we're going to multiply the top equation by 2, and we're going to multiply the bottom equation by 3. Justin has just made it so that the top has a positive 6a and the bottom has a negative 6a. All right, multiply the top by 2, multiply the bottom by 3. That's going to give us a positive 6a on the top and a negative 6a on the bottom. Then they're ready to add out. Wesley, question?
Pretty sure I heard Tristan saying negative 2.
Did he say negative 2?
I think so.
Well, if he did, it's a 2. Okay. All right. Positive 2 on the top, positive 3 on the bottom. That gives me a positive 6a on the top and a negative 6a on the bottom, and we're ready to roll. All right? So we're multiplying the top by 2 and the bottom equation by 3. Any questions on that? This is how you got to start if you're going to do the elimination method. First thought, which variable am I getting rid of? The x's or the y's, in this case the a's or the b's. Okay, how can I go about getting the x's to be equal and opposite or the y's to be equal and opposite? Okay, so then you're all set to do this next problem, right? So first off, you got to decide, what am I going to eliminate? It's definitely easier to get rid of one than the other in this one. So just say it out loud. What would you eliminate? Y's, right? Definitely the easiest. And we're one step away. Somebody tell me what to do to eliminate the y's. Rachel, thank you. What would you do to eliminate the y's? Okay, and I like to do the top when I only have to do something to one. And the reason I like to is because then I'll write the new one underneath the old one and they're ready to add up. But it doesn't really matter, Rachel. You could do the bottom one. It's fine. But I just like to do the top one if I'm only doing something one, if I can use the top one. If not, then that's fine. I'll deal with what I have to. So I'm going to multiply the top by -1. Okay, finish it from there. Go ahead and finish it from there in quad 1. So did you get 9-3? Oh boy. Ah, this is bad. Okay, so 9-3, agreed. So when you added them up, you had 7x equals 63. Be careful. What is a common mistake? A common mistake is to forget to distribute this -1 to the other side. So that's a common mistake there. You're multiplying the whole equation by -1. Everything on the left, everything on the right. So just distribute it all the way through. So be careful there. That should have gotten you 7x equals 63. Move the 7, x equals 9. Now you could have chosen either equation. The original black, the original blue. You can even use the new black, but it's a bigger equation. Usually you don't use it, but you could. And sub in the 9 for the x to get the value of y. Sometimes one choice is easier or better than the other. It just depends upon the situation, upon the problem. Any questions on that one so far? How many got that right? Okay, and that's the first one. So if you didn't, you see the error of your ways? You understand where you're at? Okay, so let's try another one. Again, we've done all this stuff last year. So the purpose right now is supposedly we're just reviewing. Okay, so take a look at this second one. And again, you've got to start with the first choice, right? This is what you should be thinking. Am I going to eliminate the x's? Am I going to eliminate the y's? To be honest with you, this one, it's like 6 of one, half dozen of the other. They're pretty similar, whether you're going to get rid of x's or y's. So let's all decide so our work will look the same. What do we want to go for, x's or y? X? Okay. So why don't we go ahead and solve for x. So you're going to go after the x's. So we're going to have to do something to one equation or both? Both, right? You're going to have to do something to both to get them to be equal and opposite. The smaller the numbers, the better, so try not to get so large. And you do have a calculator if you need it. Some say 2, some say 3.
2.
Oh, no, it's 2.
No, it's 2. Draft it in your head. Oh, no, it's 2. Yeah, I thought it was negative.
All right. -3, 2. Do you agree there? Which is quad 2, right? Negative x, positive y, quad 2. Negative x, positive y, quad 2. So everybody okay with -3, 2? Again, be careful. What students mess up on is they forget to multiply the other side of the equation. And so be careful there. Once you have the coefficients equal and opposite, you're ready to add them up. So everybody should have gotten negative y equals negative 2, which I assume you did the top by negative 6 and the bottom by 5. You could have done the top by positive 6 and the bottom by negative 5, right? You'd still end up in the exact same place. All right, you'd still end up with y equals 2. Only you'd have y, positive y equals 2 right off the bat instead of having to switch it if you went the other route. But you're still going to get y equals 2. And then again, you're going to sub that into either one, black or blue, doesn't matter. I chose black because the x was a little smaller. It really doesn't matter. Okay. So this is definitely consistent and independent because we've got a point of intersection. Everything's good to go. Questions, Wesley? Questions? Questions? Rachel? At the end, to get the second one, it does not. It does not. And you can use any of the 4, but generally the ones you multiply are bigger. And so you usually don't want to use them because everything's bigger. And then you're dealing with bigger numbers. It's easier dealing with the smaller. And in this choice, it really didn't matter. Sometimes, let's say you solve for y, and this top one had just x equal, and the bottom one had 6x equal. Then I would have chosen definitely the top one because the x that I'm looking for has no coefficient. It's a little easier. But does it matter? No. You'll get the same answer no matter what you try. Curly.
So, you know how you put negative 6 on top? Could you have put negative 5 on the top?
Yes. So you could have done a positive 6 on the top and a negative 5 on the bottom. But one had to be negative and one had to be positive because you need 30 of them to be positive and 30 of them to be negative. And no problem switching that. You would end up with positive y equals 2 right off the bat. Any other questions on that? Okay, so that's the method, right? I'm not going to do a ton of examples because it gets to be the same thing over and over again. But you got to get the procedure down is really, really, really the key. All right, so let's deal with then a couple special situations. Okay, so you go about doing substitution or elimination. And what happens is your variables disappear. Your variables disappear. That can happen. You're doing substitution, you're doing elimination, all of a sudden the variables are gone. Whoosh. Okay. So what you have to do is you have to read what's left. This is the same thing we did with inequalities, I think. Right? Same concept, right? So, if what's left is true, so let me pause for a minute, get you to think of what's going on, get you to understand the scenario. So, for example, as we were doing this problem, what if instead at the same time the y's also added out? Maybe that was a negative 24, not a negative 25, and there would be no y's. We would have gotten 0 equals negative 2. That would be a false scenario. If we would have gotten 0 equals 0, that would have been a true scenario. In the elimination method, you always have the variables on the left and the numbers on the right, so it's always going to be 0 equals 0 to be true. Doing substitution like last night, you could end up with something like 7 equals 7, negative 9 equals negative 9, 3 equals 3 to be true. But in elimination, you always get a 0 on the one side, and therefore it's got to be a 0 on the other side for it to be the true scenario. So whenever it's true, what's got to be the situation? Come on, think. What logically makes sense? Think about systems. Think about the possibility of linear systems. And therefore, then, what must be the condition if we get a true scenario? Okay, I hear consistent independent. I hear consistent dependent, right? That's the kind of thinking you should be thinking, right? Why don't you describe the lines to me? What do you think the lines are? What do you think the lines are if we get a true result?
They're probably coinciding.
Yeah, they're coinciding.
Let me ask you this. Do you agree the false has to be the other possibility? So let's think for a second. And because if I can get you guys to think this through, then you won't have to remember it as far as you'll remember the thinking of it. So don't draw this. Just remember, there are 3 possibilities in every scenario, right? That's going to be consistent and independent, right? The second scenario would be if it's the same line twice, right? That's going to be consistent and dependent. And then the third scenario is if the lines are parallel, and that's going to be inconsistent. 3 scenarios, correct? Okay. If our variables don't disappear, guess which one it is? Consistent and independent. We're going to get a solution. Our variables didn't disappear. We got a solution. Okay, 1 down, 2 to go. We got 2 possibilities left when our variable disappears. It's either going to be consistent and dependent, same line, or it's going to be inconsistent, parallel lines. Now, logically, which one do you think would be the true one and which would be the false one? Yeah, and you can go by the blanks there and help yourself out a little bit more. But true meaning every point in the line, remember, is a solution. So when it's true, it's consistent and dependent. Consistent and dependent, they are the same line. That'll always be the case when the variables disappear and what's left is true. However, if when the variable disappears and what's left is false, they are inconsistent. Which means the null set is the solution. And look, this happened before with variables that we tried back in the solution that didn't work. We said inconsistent. It's the same scenario. Therefore, the lines have to be parallel, right? And by the way, therefore, the lines must have the same slope. Good. All right, hopefully that makes sense, right? 3 possibilities. They intersect at a point, consistent, independent. Okay, our variables won't disappear. The other 2 is when our variables disappear. It's either going to be inconsistent, parallel lines, or consistent, dependent. True is consistent, dependent. False is parallel. Any questions? All right, so tomorrow's Wednesday, so we got today's lesson, homework, and then quiz tomorrow in the key concepts so far of this chapter. All right, you've got a good 10 minutes left to get some work done in class.